Dear business partner, welcome to our second edition of AmmoFlash, the video podcast by RUAG Ammotech. First and foremost, I would like to thank you for your positive and encouraging feedback on our launch of this podcast. Today, we will provide you with some insights into a typical research and development process, the creation of a new product. We are going to start from scratch and see how initial ideas are created and how they are derived from customer requirements. How do we get from the ideas to the testing of first prototypes? Have a look. Our engineers will show you what's behind it.
In small teams of various disciplines, new ideas are developed during brainstorming. Production specialists, engineers, designers, mechanics of the prototyping department work hand in hand to find innovative and creative solutions which they analyze and discuss in detail. Many performance criteria have to be met, which makes this creative process challenging. After having evaluated some concepts, they are now being elaborated. By using software simulation tools, the engineers optimize the ballistic properties of the new projectile. Flight path, kinetic energy at faraway targets, and precision values can be predicted. In order to meet the specification by 100%, several optimization loops are necessary, always keeping an eye on the numerous parameters involved. At this point, the new product is designed using modern 3D CAD software. The designer defines exact dimensions and applies precise tolerances. He carefully elaborates raw material specifications, which later ensure a safe manufacturing process. After completion of the design, the tools required for the production of prototypes are manufactured. For this purpose, high-strength materials are used, which can withstand stresses of up to 7,000 Newton per square millimeter. This is equivalent to a 40-ton truck hanging on an 8-millimeter wire. This is essential because the tools are exposed to enormous forces in a press in the next step. State-of-the-art precision manufacturing equipment allows us to keep the smallest tolerances on the prototype tools. Every part is tested and inspected before use. Deviations of 1/10,000th millimeter can be detected. This corresponds to 1/1000th of a hair diameter. Such fine-grained deviations are crucial because they determine whether the forming process succeeds or fails. The completed set of tools are built on a servo press. These presses assure 100% alignment of the upper and lower tool parts. Every work sequence is clearly defined in the numeric press controller. The press we are looking at has a nominal forming capacity of 20 tons. During every working cycle, the forces applied are measured and recorded. These results can then be used for future design and development of tools and machinery for the mass production. Every intermediate step is completed by a quality inspection during the manufacturing of the shown prototype bullets. As soon as a new prototype bullet is ready, hand loading of first cartridges is done at the shooting range. Carefully selected high-performance propellants are weighed and filled into the case. The employee makes sure that the change tolerance is kept to within a few milligrams. Now the bullet is assembled manually on the reloading press. Finally, a gauge is used to check that the cartridge conforms to the maximum permitted dimensions. Now it gets exciting. The first cartridges are ready to fire. Precision barrels are firmly fixed in a rig which can be oriented both horizontally and vertically. This equipment is used to evaluate the precision of the cartridges. For example, the firing distance is set to 300 meters. Together with the point of impact, the operator measures the muzzle velocity and also the speed curve of the projectile as it flies down range. The engineers will later compare the recorded data with the simulated predictions and define adaptations where necessary. Sometimes an in-depth analysis of a projectile is necessary as it leaves the barrel. The development team uses a high-speed camera which is capable of shooting up to 1 million frames per second. That is about 40,000 times faster than regular video speed. Extremely bright and powerful spotlights with several kilowatt output are needed to get accurate and conclusive images. These video sequences show the land and groove marks on the inside of the barrel. The sequence is used to verify if the bullets fit correctly in the barrel without too much press fit. Any improper deformations can be detected. Large angle of attack, damages on the jacket, or excessive powder traces on the bullet can also be detected. After having fine-tuned the new cartridge, it is ready for mass production. Our customers can rely on a technically well-engineered product.
As you see, product development is a thrilling and challenging job. If you would like to get a deeper insight or if you have any questions, please don't hesitate to contact us. And also, come up with your feedback and let me have your suggestions on topics for one of our next AMOFlash distributions. Next time, we will show you how we employ high-tech measurement technologies to ensure the unique precision of our products. Thanks for watching, and your strong support is our partner. Stay healthy.